Hey, hello everyone, how are you all? Okay, I hope you all will be fit and fine and welcome to this engineering mechanics channel. And today we are going to discuss about force system, types of force system, and what is resultant, what is direction of resultant, what is position of resultant. I will clear all the details about this definition, about these formulas, about resultant, about anything. I will clear all the details from basic to the end and then after that we will solve out this 11th number of problem, and this problem is based on concurrent coplanar force system. Okay, so next, what is force? If you want to pull off an object, then you are applying a tensile force. Generally we have three types of force. Okay, if you want to push, this is pull and this is push, then you are applying a compressive force. Okay, next, if you want to take a moment, then you have to apply shearing force. This is positive. If you want to take movement, then you have to apply shearing force. Generally we have three types of force. Okay, so this was all about force, and the unit of force is Newton. You know about force, everybody, I think. Next, force system. Generally we have two types of force system. First is coplanar force system and second is non-coplanar force system. So we are talking about here force system. Generally we have two types of force system. First is coplanar force system and second is non-coplanar force system. Okay, now what is coplanar force system? When all the forces lying on a single plane, then that force system is known as coplanar force system. Means when all the forces lying on a single plane, that force system is known as coplanar force system. And when all the forces lying on a different plane, then that force system means this third plane, this is Z plane, then that force system will be non-coplanar force system. Okay, what next? Here we have four types of coplanar force system. Watch carefully, this is the most important part of this video. We have four types of coplanar force system. First is collinear force system, and the second is concurrent coplanar force system, and the third is non-concurrent coplanar force system, and the fourth is parallel force system. Okay, watch carefully. Parallel force system, then we have two types, like parallel and unlike parallel. Okay, now what is collinear force system? When all the forces remain on a single axis, okay, then that force system is known as collinear force system. Watch carefully, this is your single axis, all the forces lying on a single axis and collide with each other, then that force system is known as collinear force system. Okay, next, concurrent coplanar force system. This is the important part, and all the problems remains based on, maximum problems remains based upon concurrent coplanar force system. Okay, then watch carefully. Concurrent coplanar force system. Okay, this is an example of concurrent coplanar force system. Watch carefully, this is the point, and there are 1, 2, 3, 4 here, four types of inclined forces, and when all the forces remains passing through a single point, then that force system is known as your concurrent coplanar force system. And in the next, when all the forces remain passing through different point, then that force system will be non-concurrent coplanar force system. This is an example of concurrent coplanar force system. And next, if all the forces remain passing through a different point. Okay, there are 1 2 3 4 and 4 forces. When all the forces remain passing through different point, then that force system is known as non-concurrent coplanar force system. Now next, parallel force system. When all the forces remains parallel to each other, then that force system is known as parallel force system. Like example, what will the example of parallel force system? When all the forces will be parallel to each other, this force system is parallel force system. And this is an example of also like parallel force system. In unlike parallel force system, the direction may be opposite. Okay, in like parallel force system, the direction of parallel forces will be same, and in the unlike parallel force system, the direction may be different. That should be this. Okay, this is unlike parallel force system. Parallel force system. Okay, now what is resultant? Now what is resultant? We have to find out in 11th problem here resultant, direction and position, but you have to know what is resultant. Okay, first, according to Newton's first and second law of motion, according to first law of motion, suppose this is your car and these are headlight of your car, these are steering of your car, and these are tires of your car. Okay, leave it. Okay, suppose here are 5 person, 1 2 3 4 5, and those are applying 500 Newton of force to move it into the backward direction. So according to first law of motion, okay, watch carefully, if here 5 person also and those are applying 500 Newton of same force to move it into the forward direction, then your body will be remain in rest or uniform motion, because here resultant is 0, because 500 Newton will be cancel out to each other. Okay, so according to Newton's first law of motion, your body will be remain in rest or uniform motion till an unbalanced force is not applied on it. That unbalanced force is your resultant. Here unbalanced force is 0, means your resultant remains 0. So we have a direct formula for resultant to find out the resultant, that is summation of f of x square plus summation of f of y square and root of these both. You can put directly it into this formula. This, suppose this is x-axis and this is 500 Newton of force and this is 500 Newton of force into the forward direction, into the backward direction, into the forward direction, then you can find out resultant easily. R is equal to summation of f of x square. Summation of f of x here will be 500 Newton is going into the right side direction, you have to take positive, then 500 plus, if 500 Newton is according to x-axis, because x-axis remains here plus x, here minus x, then you have to take this negative, 500 take this negative and square of this both, this will be 0, then your resultant will be 0. Okay, so according to first law of motion, your body will be remain in rest or uniform motion till an unbalanced force is not applied on it. This unbalanced force is 0 here, so this body will be remain in rest or uniform motion. Okay, and according to second law of motion, watch carefully, if you are applying, suppose here 3 person more and those are applying 800 Newton of force, 800 Newton of force to move it into the forward direction, then according to x-axis, this is plus x, this is minus x. Okay, here are two forces and both are horizontal forces. Okay, then your resultant will be 300 Newton and this car will be moved into the forward direction. How? According to x-axis, according to your resultant formula, take R is equal to summation of f of x and square of this. Summation of f of x means 500 Newton is going into the right side direction, then take 500 Newton plus minus 800 Newton of force according to this axis is going into the leftward direction, then take negative. So your resultant will be square of this both and root because vertical force is not available here, so this is not available here, so square of this and root of this, so is equal to minus 300 and square of this and root of this. So your answer will square will be cancelled out with root, so your answer will be 300 Newton plus, because answer is in square. Okay, so this is your resultant. According to second law of motion, Newton's second law of motion, the body will be moved in the direction of resultant force. So here the body will be moved in the forward direction, and here resultant is 300 Newton. Okay, so according to this formula, I think you have clear all the details about resultant. Next, what is direction of resultant? Here this car is moving to the forward direction, it with the x-axis, means your angles remain 0 degree. So in other case, you can take this example directly. Here in the concurrent coplanar force system, 4 forces are available. Okay, due to these 4 forces, and these all the forces are inclined from at an angle of theta, 45 degree, 60 degree, and here angles are not available. We will try to find out this, okay, into the next video. But here we are talking about what is the direction. Okay, resultant may be forward direction, backward direction, upward direction. Resultant may be inclined, resultant may be anywhere according to the force and according to the resultant. According to the resultant means, according to Newton's second law, the body will move in the direction of resultant force. Here are 4 forces, and we will summation of all. We will do the summation of all these forces. Then your resultant will be moved in the single direction. So according to this law, plus y minus y, this same here. Okay, your resultant can be here at an angle of theta from the x-axis. Your resultant may be here at an angle of theta, may be here at an angle of theta, or can be here at an angle of theta. We will solve out this in the next video, but I am trying to solve what is direction. Direction means this angle theta is your direction. At what angle from the x-axis your resultant is going on. So we have a direct formula for to find out the direction, that is theta is equal to tan inverse of summation of f of y divided by summation of f of x. You can find out directly the angle of theta where your resultant will be going on from the x-axis. Okay, next, how can you find out the position? Generally in concurrent coplanar force system, if you when you are trying to resolve, when you are trying to summation of horizontal and vertical forces, then you are directly in the situation to find out the position of resultant force. How? Suppose this is x, this is minus x, this is y, and this is minus y. If you want to try the summation of all the horizontal forces and summation of all the vertical forces, then your answer, you will get an answer. Your answer may be x may be plus and y may be also plus. Okay, according to your answer, your resultant will be move in the first quadrant. If summation of horizontal forces is plus, summation of vertical forces remain plus, then your resultant will be going in first quadrant and at an angle of theta from the horizontal axis. Okay, same case will be applied in these four quadrant. If your x is negative and the summation of f of y remains positive, then your resultant will be in second quadrant. Okay. Next, at an angle of theta from the x-axis. Okay, next, your resultant may be there at an angle of theta if your summation of f of x is negative and f of y is negative. Okay, so next, your resultant may be here resultant and the direction of resultant and the position of resultant will depend upon the summation of horizontal and the summation of vertical forces. Okay, next, if the summation of vertical forces is minus, summation of horizontal forces plus here and vertical forces minus, then your resultant will be in fourth quadrant at an angle of theta from the x-axis. Okay, I think I have cleared all the details about force system, resultant, direction and position. If this video is so helpful for you, then please like, share and subscribe this video. And in the next video, we will try to solve out this 11th number of problem, and this problem is based on directly concurrent coplanar force system. Okay, one important thing, that is there is use of Vergnon theorem in concurrent coplanar force system? No, because Vergnon theorem is used for find out the position only, and here during the summation of f of x horizontal forces and during the summation of vertical forces you can directly find out the position of resultant force. But this is a concurrent coplanar force system. Okay, in the concurrent coplanar force system there is no use of Vergnon theorem, but in non-concurrent coplanar force system, to find out the position only we use Vergnon theorem. Okay, I think I have cleared all the details. Okay, if this video is so helpful for you, then please like, share, subscribe and comment please. If you have any problem, then please comment. Okay, thank you very much.